Now let's start with chapter 7, that are arrays. That is arrays. Arrays and its importance. Now what are array? What is an array? Array is a contiguous location of memory spaces. Continuous is together, continuous, one after another, one after another. Contiguous is one after another, but with no space left. For example, this is contiguous. There is no space between two places. Okay. Now array is a derived data type. As we know, there are only two types of data types: primitive data type and derived data type. So if array is not from the 8 primitive data types, it has to be from derived data type, right? Now why is array needed? For example, if we have to store marks of 50 students with their names, as take out the average. For each student's marks, we have to make variables, and then one variable for each, for 50 names, and one variable for the average. 101 variables would make the program complex. That's why array are used. For example, there are 50 students and we have to store their names, we have to store their marks and take out their average. So instead of creating 50 variables for the names, 50 variables for the marks, and 1 variable for the average, that is 101 variables, we can just create 3 variables. 1 array for name, 1 array for marks, and 1 variable for average. Now what are arrays? Arrays are contiguous location of memory spaces. Arrays can store many types of data in one place. Okay, this comes under encapsulation. So instead of creating 101 variable that would make the program complex, we are using just 3 variables, 2 arrays and 1 variable, to keep the program simple. Now types of arrays: single dimensional array, the arrays that store variables in this form. Multi-dimensional array, for example, 2-dimensional array. One dimension, 2 dimension. So this is 2-dimensional array, this 1-dimensional array. Now how to declare them? Data type, for example, int array name AR, then square brackets equal to new int size, for example 10. We have to store 10 int values under the array AR. So for example, if for example this is variable, this array AR, so it will have 10 places for int. 1 2 3 So this is array AR. It will use the same amount of memory space of using 10 int variables, but it becomes very easy for the programmer to refer to the variables. Okay, now he can just refer to AR and their indexes. Now how do they refer? What are indexes? We'll study later on. In 2-dimensional array, each in 2-dimensional array, each of the thing is an array in itself. For example, if this is the array, there are 4 things inside the array. Each thing is an array in itself, because this thing contains 4 things, this contains 4, this contains 4, this contains 4. So each element of an array in 2-dimensional array is an array in itself. Now using arrays to refer to a specific element in an array, we first write the array name accompanied by the index in square brackets. For example, like AR has 5 places: 1 2 3 4 5, 10 11 12 13 14. Index start from the value 0. So index of the first place will be 0, second will be 1, third 2, fourth 3, and fifth 4. So how to refer? If this is the ARR is the array name, we refer to ARR 0. So the value of ARR 0 is 10, ARR 1 is 11. Why? Because ARR is the array. First it will refer to the array, then it will check what memory space you have to access. So it will return the value of the first index, that is 0. Now arrays are typically used to conduct calculations on many different values. For example, there are 50 values, you have to conduct the operations. For example, you have to add 10 to 50 numbers, so you can just use an array instead of creating 50 variables. You just use loop arr1 arri equal to math.sqrt I plus 1 square of first 10 numbers. Why we are using I plus 1? First square of first 10 numbers, we just start with 1. Why? Here we are using I equal to 0 just for this reason, because the index start from 0. If we had written it as 1, it would start from 1. So it would have been an array, the first index would have been left out. So that's why we use 0. And then here we are using I plus 1 because in the first time when the loop runs, it will become 0 plus 1, that is 1. So it will return the square of 1 and not 0. Now one important error that we commit, not the computer, out of bound error while writing. Okay, while writing in the paper, you may your marks may be deducted and you wouldn't know why. Out of bound error. For example, ARR. Okay, it has the length 5, but you are referring to the 6th number. For example, if ARR I equal to ARR I plus 1 and loop I equal to 0, I smaller than equal to 5, I plus I smaller than 5, I plus plus. So when this loop will run, when this loop will run, first time it will check ARR 0 equal to ARR 1. Okay, no error. So when it runs, ARR 4 will come. ARR 4 because smaller than 5, ARR 4 equal to ARR 5. Now as we know, indexes start from 0, and if the length is 5, the last index will be 4. There is no ARR 5. So the computer will show an error known as the out of bound error. This is a silly mistake that many students commit in the written exam. In the practical exam, you will encounter this problem. If you write this, it will show, and the blue jay will show that error. So out of bound error is a thing that you have to check. So instead of writing I smaller than 5, we write I smaller than 4, because I3 equal to 4. 4 is the last index, so it will check, and out of bound error is fixed. Simple. Now topic number 7.4, searching in one dimensional array, linear search. For example, you are searching for something and you have to search for an element in the array, and you have to print out the index. You have to take out the index of the number. Okay, so we'll write a loop I equal to 0, I smaller than the length of array, I plus plus, if array name I equal to, for example, we are searching for the number 5, so it will do the task. Okay, simple. We are searching, we are using the loop. The variable running the loop will be used as the index number every time the loop runs, and if the place with the index number of the loop, of the variable running the loop, is equal to the thing we are searching, it will perform a task. This is the easiest form of linear search. Then comes binary search. Binary search, while lower limit is smaller than equal to upper limit, it will run. Okay, then middle value equal to lower limit plus upper limit divided by 2. For example, 0, 1, 2, 3, 4, 5. Now middle value equal to lower limit plus upper limit divided by 2. 5 by 2 equal to 2. Now you may ask, how is it correct? It will become 2.5, but we are using int by int equal to int, so it will return 2. The decimal values will be rejected. M will become 2. L M U. If n is smaller than a, for example, this array is a, and n is the thing we are searching for. For example, if n is 1, is 1 smaller than a index number 2, 0 1 2, is a smaller than the value at the index number 2, the index number at index number 2, the value is 2. Is 1 smaller than 2? Yes. L equal to m plus 1. So now what was our L? M was 2, L was 0, U was 5, sorry. U was 5. Okay, so our upper limit is 5, lower limit is 0. Why? These are the index number. Do not confuse with the values. These are the index numbers: 0 1 2 3 4 5. These are the values, these are the index numbers. The lower limit is 0, upper limit is 5, sorry, middle is 2. Now L equal to m plus 1. L will become, if n is smaller than a, so it will become 3. Now L equal to m plus 1, lower limit 3. Sorry, this is an error. These both will be interchanged. Okay, now U equal to m minus 1. U equal to m minus 1. M will become 1. Okay, now the loop will run again. Why? Because L is smaller than equal to U. Is 0 smaller than equal to 1? Yes. So it will run again. M equal to L plus U divided by 2. 0 1 1 by 2 0.5. It will become 0. 0 is n 1 smaller than 0? No. Else if 1 greater than 0, yes, you will become, L will become m plus 1. So L will become m plus 1. L is now 0, 1. Now it will run again. M equal to L plus U but divided by 2. L plus U, while it will run again because L equal to Y is also there. L equals to U, so it will run 1 plus 1 divided by 2, that is 1. Okay, now M is 1. If n is 1 smaller than 1? No. Is n greater than 1? No. Else flag equals to 1. Therefore we have searched for the thing and the index value at which it is stored is m. Okay, this is how we do the searching. This is a very complex thing. If you write a program, you'll understand it. Okay, now comes sorting. So how the sorting is done? First we'll bring the smallest number to the front. So sorted 6, unsorted 25, 43, 87, 54, 90. This is the increment, this is the ascending order of sorting. Okay, so sorted 6, the smallest number is 6, so the 6 will come first. Then from the unsorted, the smallest number is 25, so 25 will come. 6, 25 sorted, 43, 87, 54, 90 not sorted. Then from this the smallest number will come 43. Then from this the smallest number will come 54. Then from this the smallest number will come, and the last this number will come. So this becomes our sorted array. Now how we write this? Okay, we are just accepting till here, public class sorting void main. We are accepting till here, and then we are declaring two int values, smallest and temp value. For x equal to 0, x smaller than 6, x plus plus 5, because the length is 6. If array y, if arr y is smaller than smallest, temp value equal to arr x, smallest arr equal to y. Let's create a buffer. Okay, let's create a buffer. X, y, smallest temp. Okay, now smallest ARR equal to x, first our value is 0, smallest is nothing till now, smallest equal to ARR x. For example, ARR is 56213 2, it will be 7, so ARR 2, that is 6, smallest will become 6. Now y equal to x plus 1, 1. Temp value, if ARR 1, ARR y smaller than the smallest, is the value at index 1 is smaller than 6? No. Is 2 smaller? Yes, smallest will become 2. Is 1 smallest? Yes, 1. And then it will run. Is it smaller? Anything smaller than this? No. So temp value will become ARR x. Temp is 6 now. Temp is 0, sorry. Temp is 6 now. Smallest equal to ARR y. ARR y, that is 1. ARR y equal to temp value. So ARR y, that is our 0, 1, 2, 3, 4, 0, 1, 2, 3. This will become 6. ARR 6 equal to smallest. This will become 0. So this will go on and on. The smallest comes first. Smallest come first, that is 1 will come here. This will go on and on and on till we form an ascending order. This was chapter 7. Sorting and searching are two very complex processes you have to learn in deep. Try to look for other sources as well, not just this course. The notes are available for download. You may install it, you may learn, see this course again, you may study the notes and create a buffer of yours and do this thing. Create a buffer of yours and try to understand the program, okay, and revise the notes later.